Again, good morning, everyone. Our topic for today is experiment number 8, parallel plate capacitor. So in this activity, we are going to study the relationship between, number 1, the capacitance, of a parallel plate capacitor and the separation distance between the plates. As you can see, a parallel plate capacitor is made of two plates with a distance between them. And sometimes this distance, or the gap we call it, has a material, a non-conducting material in between, which we call a dielectric. Okay. From here, we are going to calculate what we call the electrical permittivity of free space. It's actually a constant. Okay, we'll calculate this constant. And then later, if we have the chance, we will study the different effects of what we call the dielectric material and to determine the dielectric constant. Okay, so it's actually a very simple experiment. So let's move forward to how we will find the permittivity of free space by using the separation distance and capacitance. Okay, so here's the table that you are going to make. Now, in the lab, we measure the diameter of the plates in centimeter and change it to meter so that later we can calculate the area of the plate. However, since we are doing it by simulation, the area of the plate will be given directly. Okay, so the simulation is already open for me here. Let me just scroll this down a little bit. Okay. So the simulation is already open with me. It's actually this one here, okay? So when I give you the copy of the simulation, okay, the link, I will put it in the chat. You will open capacitance, okay? And from here, you will get it like this, where we can adjust the distance between the plate, okay, and the area of the plate. So what's going to happen here is it's going to be up to you to choose your own area. You will choose your own area, okay? But the separation distance, you will follow the table, okay? You will follow the table separation distance starting from 2 millimeter, which is the smallest gap provided by the simulation, okay? So here you can see 2 milli. So here you will write 2 millimeter, okay? What's the next separation distance that we can select? Can we go with 3 milli? Actually, you can go by a fraction of 2 milli. Okay, so 2.2, 2.4, 2.6, 2.8. You can go 3 milli and the maximum distance of 10 millimeter. Okay, so it will be your choice about the distance. You can go 2, but then 2.2, 2.4, 2.6, and so on. Or you can even choose, if you want, 2 milli, 3, 4, 5, 6, 7, up to 8 milli, because the simulation will go up to 10 millimeters anyway. Okay? But the plate, again, you have to choose your own plate. Okay? And when you choose your own plate area, you have to keep it fixed. So for example, the plate area here is 400 millimeters square. So you will write the area below, okay? 400 millimeter square. You have to take note that you will convert that to meters squared, okay? I'm going to show you how to convert if you want to see it. But anyhow, let's continue with our table. So again, we don't need the diameter because the area is directly given, okay? The separation distance from millimeter, you have to change it to meter. So how do we change millimeter to meter? Anyone? Anyone want to answer? How do we change from millimeter to meter? Anyone? Or I should call name? Okay, let's call name. Mustafa. Mustafa Al Safwan. How do you change from
Yes.
meter to millimeter?
Uh, Multiply 1000.
Multiply or divide?
Divide.
Okay. you can divide by 1000, or you can actually multiply by 10 raised to minus 3. Any of these two methods is the same, okay? But we'll take divide by 1000. Now, one tip I can teach you if you are at home, okay, is to use Microsoft Excel to do simple calculations. So how do you make simple calculations using Microsoft Excel? Okay, I'm going to put Microsoft Excel here. I'm going to write my millimeter value, 2, 3, 4, up to 8. Okay, and then I will take an equation equal sign 2 divide by 1000, and I get the answer over there, right? Click the first number, drag it down, and you will see everything will be divided by 1000. Another technique, okay, you can copy this and then write it in D, okay? Another technique is this. If you are going to divide by 10, 100, by 1000, 10,000, or even by 1 million, is to count the decimal. So here 2.0, okay? That's the number, right? The decimal point is here. What do? If you divide, you move the point by the equal number of zeros. So for example, this is 2 divided by 1000. How many zeros? 1, 2, 3. Okay, so move the decimal point. 1, 2, 3. And put the decimal point here with the 0. Okay, so this becomes 0.002. So those are techniques that you can employ when you want to divide very quickly without calculator. Okay, so this one is actually quite easy. So D in meters, 0.002, 0.003, 0.004, and so on. I'm already filling the table for you. Okay, next is to inverse. Okay, inverse, let me see if my calculator in Windows has the inverse function. Usually it will have the inverse function. No, it doesn't have. But my calculator, the one which I use in the lab, has the inverse function. The inverse function in your calculator looks like this. It says x raised to minus 1. Okay, so that's how you'll find the inverse function. But in my Microsoft Excel, I can do the inverse. Okay, I will take this number, okay, and use 1 is equal to 1 divided by this number. That's the inverse function. Okay, again, 1 divided by this number. That's the inverse function. So you can just take and drag. And we can make it format cells so that all of them will have only no decimal there. So as you can see, it's quite easy to make the inverse function in Excel. Okay, so I will take those numbers and write it on my data sheet. So this is 500. This is 333. This is 250. The next one is 200, 167, 143, and 125. So there you go. It's quite easy because this is only by calculation. The last row, you have to make capacitance reading. So this is where we go with our simulation. We'll start with 2 milli. Okay. So I'm going to use a plate area of 400 millimeters squared, and the distance is 2 milli. The capacitance reading is directly at the top, 1.77 picofarad. Okay, so go here and write 1.77 picofarad. Now take note that in the lab we are using a capacitor with a range of nanofarad. So here you will simply replace nano, just replace it with picofarad. Okay, so again, nano, replace it with picofarad. What's the difference between nano and picofarad anyway? Nano is times 10, raised to minus 9, and pico is times 10 raised to minus 12. Okay? So here we record 1.77 picofarad. The next value at 3 milli. Okay? Go back to the simulation. Just slide your capacitor until you get 3 milli. Okay, let me use my mouse. There. So 1.18. Go back to the data and write 1.18. Okay? Until you complete again the table. Remember that you will choose your own plate, okay, area. You will choose your own distance. But for me, I chose to keep the distance simple by using 2, 3, 4, 5, 6, up to 8 millimeter. Once you have completed the table, you will go to the calculations. So forget about table 2 now. We can go to table 2 later. You can go to the calculations. And the calculations is actually quite simple. First, we have the area in millimeters squared to change it to meters squared. So how do we change from millimeters squared to meters squared? Actually, the technique is like this. If you write 400 and then millimeters squared, multiply it by 1 meter, and what's the equivalent of 1 meter in millimeters? In centimeters, it's 100. In millimeters, it's 1,000. So 1,000 millimeter. This will cancel millimeter and square. Okay, but it does not remove millimeter here, only the square. So you have to multiply it again. 1 meter over 1,000 millimeter. This will cancel millimeter and millimeter here. Meter by meter will give you meter squared. Okay, so you simply take 400, multiply by 1 over 1,000, multiply by 1 over 1,000. The answer will be here. Okay, so calculate the area of the plate from your side. Next, the slope of the line means you have to graph capacitance versus 1 over D. So it's a good thing that we have Excel because we can graph in Microsoft Excel just like I've shown you before. Okay, good thing that we have already the data from Microsoft Excel. What's the data? This is the distance, the separation distance between the plates in millimeter. This is the separation distance between the plates in meter. And this is 1 over D. Okay? And this is 1 over D. And the unit is also given in meter raised to minus 1. Okay, raised to minus 1. So we are going to graph this versus the capacitance. So you can also enter the capacitance here. And the unit is in picofarad. Okay? So what's the capacitance when the separation distance is 2? Let's put it here, 1.77. And when the separation distance is 3 millimeters, 1.18. You can, of course, again, you can complete the data so you can graph the whole data set here. But for me, 2 points will give me enough line to get the slope. Okay, I'm gonna hide the value of, no need to hide it. I'm just gonna label it. This is your x-axis, okay, x-axis, and this is our y-axis here, y-axis. Okay, I'm gonna select my x and my y-axis, but of course, again, my data is incomplete. Make sure you have a complete data. Okay. I will go to Insert, Scatter, and select the points. And I have a graph with 2 points, which is more than enough for me. Okay, and you will notice that the graph goes to 0 as well. What do you do here? Select the point, right-click, and then add trend line. Once you added the trend line, select Display Equation on Chart. And once you have the equation on chart, that is actually your slope. Okay, let me increase the size of the text. Okay, so if I add here 0 and 0, the graph will go to 0. But anyway, you can see it's going to 0. Okay, now for saving the graph, you can take snipping tool and take this graph with the table and save it. So you have proof that you did the simulation. Okay? Any questions, Shabab? This will be our slope here, 0.0035. Okay? That would be our slope. So let's go back to our data sheet and write our slope, 0.0035, and take note the unit must be picofarad. Okay, the unit must be picofarad. You have to remove pico. So in this case, in order to remove pico, you have to multiply this by 10 raised to minus 12. Okay, by 10 raised to minus 12. Once you multiply the number by 10 raised to minus 12, the remaining unit will be farad meter or farad by meter. Okay? The answer for the slope in farad meter, Hadi, you will substitute it here in this equation to find epsilon. And then you will divide it by the area of the graph. Where do you get the area of the graph? From the top. Remember, not the area of the graph, I'm sorry, the area of the plate. Okay? So the area of the plate will substitute here. The slope will substitute at the top. The calculated value for epsilon will be here. Okay? So make sure you do your calculations correctly. Take note of your units. And take note, you have to remove pico from here. Okay? Once you have the epsilon calculated, go to the next page and find the percentage error. Epsilon real minus epsilon calculated over epsilon real. Now, what is epsilon real? You will actually find the real value in the theory, which is here. Epsilon real is 8.85 by 10 raised to minus 12. Okay? Any questions, Shabab? Any questions? Any questions? Hello? No answer means no questions? Good.
No question. So, thank
Is
you.
it clear?
Yes.
Okay, thank you, Ali. Now, in table number 2, I'm going to send you a video link for the capacitor experiment, which we did during lockdown. Okay? So here, you will find me explaining table number 2. What you will do is you will take the data from this video. Okay? Take the data from this video and record it in your book. Okay, this is making the dielectric. Let me. Okay, Saleh, are you late? Let me play it. Okay, so the types of dielectric we have. This is acrylic, and the thickness of the acrylic is given. The next dielectric we have is paper. Okay, and the last one is wood. So what you will do is you will record this in your data sheet. Okay, so you have acrylic, you have paper, and you have wood. The thickness will be given in the video, and the capacitance Cx, that means the capacitance with the dielectric, will be given as well. So let's see it. Just put it forward. Actually, you can see it there. Okay, in the video, you can see it there. You can see the capacitance here, how much it is. Okay. And when I remove the paper, okay, I started with the paper. When I remove the paper, what's going to happen with the capacitance? Just wait. Let's move forward. Okay, so here's the capacitance. There you go. When I remove the paper, the capacitance will decrease. Okay, so you will record the value here. So again, Shabab, I will send you the YouTube link for the GS YouTube channel for this video, okay? And that's how you'll fill table number 2. Any questions? Basically, that's our experiment today. Any questions? Any questions, Shabab?
Doctor.
Okay, I'm gonna stop the recording now and send you the links that